Hey, hello everyone, this is Mr. Wu. Welcome back to QuickCalc. And today we're going to learn our first theorem, in the calculus classes, and the intermediate value theory. So there are a couple theorems totally in the AP calculus classes, not many. This is one of it, and they are like similar. So when you're writing the name, please write correctly, alright? Because later you're going to have very similar theory come out. Okay, so first we'll talk about the definition. One thing you're gonna notice, in these theorems, you can find out the condition kind of similar. That function f must be continuous. This is always the first condition. And this part might be different. So for this one, it's a closed interval, a to b. Alright, fa not equal to fb. And k is any number between fa and fb. Alright, so k is any real numbers, is the value of the function between the fa value and fb value. Alright, so now this is the theory actually. There is at least one number c in such a to b such that fc equal to k. That means there exists at least one real value c between the a and the b in this interval on this function. That's what this theorem is. Kind of a little bit confusing. So of course I always use graph to explain. Alright, so let's take a look. So let's look at the left side. There's a function fa value on the top, the fb values on the bottom. Alright, we fit the theory. First, it's continuous, right? There's no breaking point on the left. And the two values are not equal. Alright, and it's a closed interval. So we check these three parts. First, now we can apply. The question meaning is, if the k value between fa and fb, so we know if the function value, there must be a point which can make the whole function value equal to c. Very easy. Like this point, it's a c, right? This point can be c. This point can be c. So at least one. All right. So when you hear this thing, you feel like, this is like obviously why we learned this. Well, a lot of theorems are obviously from the beginning, but later we have some applications. All right. So let's look at a counter examples. So fa we fit, fb we fit, they're closed we fit. Okay, this is not continuous because you see there's a breaking point. So this theory cannot be applied here because you can find out it's not always true, right? They say must have a value c to make this thing equal to k. Unfortunately, no. If my values k is right here, there's no c here. So that's why they just show you it must be continuous. That's a must be necessary. All right. So how are we gonna apply this theory? It sounds like a very obvious theory. So let's use one example. They say use intermediate value theory to show that the polynomial function, that one, has a 0 in the interval 0 to 1. Alright, so this is the equation, and let's check. Well, always check continuous first. Is that continuous? And let me switch a color. Yes, it is continuous. Right? It's a cubic function, so you know something like something this. Right? It must be continuous. There's no breaking points. Second, closed interval. Yes, closed. Also check. Right. Third, let's check. fa, which is f0, equal to plug in -1. f1 we plug in is 3 minus 1 is 2. They are not equal. So check. Now we can use the theory. Yes, we apply the theory to prove there must has at least one value to make the function is 0 between these two, because 0 is greater than -1, less than 2, so it must exist more than one value. Maybe one, maybe more than one, at least one between these. So that's how we applied intermediate value theory. Alright, thanks for watching. If you like my video, please subscribe. And today I'm going to keep going. Alright.